Hello everyone, today we are going to start with chapter 1 of grade 10 maths, real numbers. What are real numbers? We've already done it in our previous classes that real number, they are a set of rational as well as irrational numbers. We have learnt rational numbers are those which can be represented in the form of p upon q, where the denominator q is not equal to 0. On the other hand, the numbers which cannot be represented in the form of p upon q are not rational numbers, they are known as irrational numbers. So, when rational and irrational numbers are grouped together, they form a set of real numbers. Now, under this chapter, real numbers, will be studying some important properties of real numbers, the first being Euclid's division lemma. Euclid's division lemma is a very important concept as it helps us, because it has already helped us to find the concept of HCF and LCM and also division algorithm. Let us try to understand Euclid's division lemma by taking this very simple example. Suppose we have 63 pencils to be arranged in 5 boxes. We have 63 pencils and 5 boxes, and the number of pencil in each box is 12. Each box has a capacity to hold 12 pencils. Also, we have 86 erasers, 32 sharpeners and 10 ball pens to be arranged in 8 boxes. So, 86 erasers to be arranged in 8 boxes, and the capacity of each box is holding 10 items. Similarly, we have 32 sharpeners to be arranged in 4 boxes, and the capacity of each box is 8. We have 0 boxes for 10 ball pens, they have to be kept loose, and the capacity of each box, if it was there, was supposed to be 15. So, if I arrange it in the form of a table, because all these numbers are looking very complicated, let us tabulate them in a systematic manner. Pencils, how many pencils each box can hold? 12. How many erasers each box can hold? 10. How many sharpeners each box can hold? 8. How many ball pens each box can hold is 15. How many boxes do we have? We have 5 boxes for pencils, we have 8 boxes for erasers, we have 4 boxes for sharpeners, and we have no boxes for ball pens. They have to be kept loose. Now, let us come back to the number of erasers, sharpeners, pencils and ball points that we have. We have 63 pencils. Since we have 63 pencils and 5 boxes, each box holding 12 pencils, obviously 3 pencils would be left extra. There will be no place for the remaining 3 pencils to be put in the box. Similarly, we have 86 erasers, but there are only 8 boxes, each holding 10 erasers, and as such, how many erasers will be left? Yes, 6 erasers would be left loose, not fitting in the box. Similarly, we can see we have 32 sharpeners, and these 32 sharpeners have to be arranged in 4 boxes, and it will fit exactly, because since each box is holding 8 sharpeners and there are 4 sharpeners, 8 into 4 will give me 32, and there will be no sharpener left. So, as we can see, the leftover is, or the extra item which has to be kept loose, is 0. Next, how many ball pens do we have? We have 10 ball pens, and there are no boxes for it. So, since there are no boxes for it, 10 ball pens will have to be left loose as an extra item. If I add the leftovers to the items packed in the box, that will give me the total. So the total number of pencil has come to be 63. And how did we get it? 12 into 5 plus the extra. 12 into 5 pencils in the box and 3 extra has given me 63. Similarly, 10 into 8 plus 6 has given me 86, and 8 into 4 plus 0 has given me 32. 15 into 0 plus 10 has given me the total item as 10. Let us generalize this rule and see whether this rule holds true in other situations also. We have just seen this arrangement, how to find the total item, the leftover, and the total item and the leftover items. So how did we get it? The first column multiplied by the second column plus the third column has given me the total, and it is true for each of the column. It is true for each of the column. So if I generalize this, how do I generalize this for all numbers and all situations? If I consider the pieces per box, the pieces of item per box, if I denote it by an integer b, because these are items and numbers, they have to be positive integers. It is very, very important. These numbers cannot be negative, because if we are taking some real life example, the materials cannot be negative. The objects have to be positive in number. Number of boxes 5, 8, 4 and 0, and let us denote the number of boxes by Q. Extra items by R and the total by A. So what do we see, that how did we get A? In every column and in every row, the same rule has been applied. What is the rule? The first multiplied by the second added to the third is giving me the fourth column. So if I generalize it, I will write A is equal to B into Q plus R. So this is my Euclid's division lemma, which is derived like this. And what does it state? That any real number, any real positive number A can be broken up, or it can be broken up as B into Q plus R, where B, as per this example, is the number of items per box, Q is the number of boxes, and R is the leftover. So we have been doing this all through while doing division also, that I consider this A to be my dividend. Dividend is always equal to quotient into divisor plus the leftover remainder.